Hello everyone, I'm Dan, and today I just want to talk a bit about Fusion. You see, something I've been observing a lot recently is that Fusion is overthought, right? We live in a world full of libraries that try and get around what Lua does, that try and do things in the background, that work at such a high level of abstraction that you don't know what's going on anymore. And Fusion really isn't like that. Fusion is very tangible, very physical, very not abstract. And in order to get really proficient at Fusion, you are going to need to abandon this mindset of the library doing things for you. Fusion does not do very much of anything for you. So with this in mind, let's start by talking about the first thing that people overthink, which is the syntax. So if we go to this here, this little new UI padding, I'm just picking on it because it's a very small one. And you can see we have this very weird syntax here. It's like new, and then you just put a string here and then a table right away. This doesn't look like standard Lua. What is this? Well, it actually is standard Lua. I know, it's a bit confusing, but let me explain. So if we create a new file and set the language, let's make a function. So this function do stuff with X, and we'll just print it out. We are all in agreement that this is just a standard Lua function. There is nothing special going on here. And in fact, we can call this with anything. So do stuff with to, or do stuff with true, or do stuff with foo, or do stuff with a table where blue equals shoe. So there are two examples here that are notable. The first one is this one, which is a string literal, and this one, which is a table literal. So a string literal in Lua is just whenever you explicitly type out a string, whenever you have the quotation marks, that is a string literal. You're saying explicitly what that string is. You're not using a variable or anything. Same thing with table literals. This is when you explicitly write out a table, right? This could be anything from like an array, a dictionary, whatever. As long as you have those two brackets and you are writing explicitly the values, that is a table literal. Now in Lua, there is a bit of syntactic sugar that allows you to call this function without the parentheses. And this is valid syntax, by the way. Lua recognizes this exactly the same as it recognizes this. It's just calling a function with a single argument. And this might look a bit confusing at first, but the reason we do this in Fusion is to keep our code clean. It is up for debate whether we should do this. It breaks some formatters after all. But this is a standard feature of Lua. This is something which you can do regardless of whether you're using Fusion or not. So with that, let's actually take a look at what new looks like. So new is a function, takes in a class name, I don't know what that was, class name, type string, and it returns a function. That might surprise you, but I'll explain. So this function takes in props, which is just going to be the type table. So just any for right now. Doesn't matter the exact definition here. And it returns an instance. This might not be what you thought the new function did. You might have thought the new function takes in the class name and the props at the same time and returns an instance. But what's actually happening here is it returns function with props, type, I don't know, any, and returns an instance. We can actually clean this up here because we don't need to define this twice. Then this will just do instance equals instance dot new class name, apply the props, return instance. Right? Very, very simple implementation of the new function. In fact, it's not even functional because we're not actually applying the props. But this is basically how the new function works. And so when we go to write our code, we can then say local text label equals new text label, and then text equals hello. Now your first thought might be, okay, this makes sense, But why are we doing it this way? And the way to think about this is that new is creating a component, right? This is a component creator. When we say new text label, we are creating a component function, right? So just the same as like you can do local function greeting with like props or whatever, and then, you know, create greeting and return it, right? New text label is essentially creating one of these function definitions. So we can say local text label component is new text label. And then this code down here is actually, we're creating a text label component with the props that we give it. Just the same as any other Fusion component. Now, combining this with our syntactic sugar, we can get rid of these parentheses here. And you can see here, we now have the standard syntax for components, right? This is how you write components in Fusion generally. And we can also get rid of these parentheses up here, which is not really related to anything that Fusion does specifically. But what you'll now notice is that we can substitute this in here, and you can see we now have the standard syntax for creating an instance in Fusion. It's not magic. We're simply getting the component for a text label, and then we're instantiating that component with some props that we provide. Nothing magic. So that right there is one of the big confusions. The other big confusion is that for some people, they get caught up with this children syntax here, right? Just like they think it's magic, right? When we pass in new UI grid layout here as a child, they assume that some magic is going on behind the scenes, right? That somehow Fusion is like passing our script. It's like reading the source code manually and then it's automatically building a tree or something crazy. Fusion doesn't do this either. So what you'll notice in this example here is that new is just a function that creates a component, and that component in turn creates an instance. This is how components work in Fusion. It's a very standard, very general definition. And what this means is that whenever you put this in any expression, you're getting back an instance. And in this case, we're saving this instance to this text label. We're all in agreement with that? Okay. So how does children work then? Well, it's simple. Children accepts instances. So we could do instance.new folder, and this folder would be added as a child of the text label that we're creating, right? Very, very simple. And this is not magic at all. You can put whatever instance you want in there and it will try and parent it. I mean, obviously don't put something like workspace in there because you can't parent workspace. But notice something else though. We're not passing in this instance directly. We're actually passing it in as an array of instances. Now, of course, this means that we can do things like add other instances in. But what you'll notice here is that arrays of instances are also considered as children. Fusion recognizes this at any level. So we could do this and it still works, right? Because arrays of children are considered as children. The same way that instances are considered as children. And this also applies further for state objects. If we had a state object, say for example, local my folder equals state, and then later on we set my folder to instance.new folder, right? So we're storing a folder inside of our state object. We can put my folder in as a child like that, and a state object containing an instance is considered as a child. We could go even further with this. We could even put an array of children in there, and we're sort of pushing the boat out really far now, where we have this sort of like chain going on, where we have an array containing my folder, containing an array containing like folder and bool value. Like, it's a bit ridiculous. But all of this is all really neatly summarized by one simple definition. Whatever you pass into children is either going to be an instance, or it's going to be an array of children, or it's going to be a state object containing children. It's a really nice recursive definition. So we can pass in an instance. That's a valid thing to pass in. We can pass in an array of children. Or we can pass in a state object containing children. And notice I'm saying children, not instances, because that explicitly allows for putting arrays inside of arrays and stuff like that. So all we're doing here is we're just parenting whatever instances arrive inside of that children property. Nothing else. Fusion is not parsing your code, it's not doing anything magic. It's just accepting recursive arguments. That's all it's doing. Furthermore, another thing you'll notice here is that because we're storing this instance inside of a variable, we can use it inside of another new, right? So if we made a new folder and we said its name was going to be textlabel.txt, right? This is valid. And that means it seems obvious in this context, but what a lot of people don't realize is that this is how you can do refs in Fusion. We don't actually have to officially support it whatsoever. Say, for example, we wanted to use the absolute content size of this UI grid layout. Well, what we could do, we could just go up here, say local grid layout equals that, save that reference, then we'll go down to where grid layout is, and we just pop the variable in. And there we go, we now have that reference, and we could go somewhere else, like we could go up here to like size, and we could say udem2.fromOffset grid layout.absolute content size .x grid layout.absolute content size .y. And that works exactly how you would expect it to, right? This is all that you need to do refs in Fusion. You don't need any official mechanism to do it. There's no magic going on. None of that. This is something that I've seen so many people get tripped up on. Fusion is not magic. Now, saying that, there are 1 or 2 places in Fusion where some things are hidden from you. For example, when you're working with state objects, specifically computed objects, say local computed equals computed function, and we do return my folder get or whatever. Now, in this case, Fusion is automatically doing a bit of inference work for you, right? In Fusion, we're keeping track of what state objects you get the value of inside of that computed, and we're using that to automatically update your computed when any of those things change. That is kind of magical, but don't expect magic in Fusion, right? Especially with anywhere else you're using state objects. Because another thing that I see a lot of people get tripped up on is, well, using state objects inside of new. They assume that, oh, Fusion must be doing something magical. Again, like Fusion must be doing something outside of Lua in order to figure out what our state objects are doing. Or it's like recalling our code in order to get the new values, or it's doing something crazy. It isn't. All that you're doing is you're constructing objects and you're linking them together, right? Remember from the Thinking in Fusion video how we have the reactive graph? Well, every single point on that reactive graph, every single box, that is just a unique object in your code, right? So local foo equals state2. State is just a function. It constructs an object and it returns it, and it stores it in foo. And then local bar equals computed. Going to return foo get times 2. Again, this is not magic. We are constructing a new object. We're passing in this callback to the object for it to use. And that object gets stored in bar. No magic. And then later on, when we go to use it in something like a folder, and we set the name equal to bar, this is not magic. We are just saying we're passing in this object as the value of the name property. There is no magic here whatsoever. And so when you see syntax like this is just we're constructing an object and then we're directly passing it into the name property. There is no fancy parsing going on here. It is all completely standard. So there are plenty more examples of ways that Fusion isn't magic. For example, with syntax like on event activated equals function. Like this is not magic either. Like on event is just a function. We're calling it with a string. It returns a key that we can use with this new function. The rule of thumb with Fusion is that Fusion does as little as possible. It really sort of almost tricks you into doing the heavy lifting. And that's a better model because it keeps the library simple, it keeps it fast, and it keeps it understandable. So generally, don't expect Fusion to do anything for you. Don't expect magic to come about. Right? You will not encounter magic in Fusion, except for one or two very, very rare occasions. So with that out of the way, I just want to share a bit of further speculation about why do I think people get confused with this? Because, I mean, this is not complicated stuff. I think it's a combination of, firstly, not having seen stuff written like this before, and secondly is using libraries like react, or maybe even pract, or, I don't know, what's the other one? I forgot, but using those other UI libraries which do work at a much higher level of abstraction. This is not a knock on these other libraries, by the way. If you enjoy using them, use them, please, by all means. I'm not here to dictate what you use. But what I will comment on is that these libraries work at such a high level of abstraction that it's very difficult to tell what's actually going on at the level of individual lines of code. Like, think about, for example, how react abstracts away the entire process of dealing with instances. Do you know what react is doing to your instances? And do you know how often it's doing stuff to your instances? Do you even know whether it's applying the correct optimizations to make your instances generate faster? You don't, because it's so abstract that that is considered an implementation detail and is variable. It's likely to change. You have no control, and you have no way of feeling what's going on. In Fusion, this is not the case, precisely because Fusion is very minimal, right? We don't have big processes like that going on, generally speaking. Like perhaps the biggest process that Fusion does is updating state objects, which is done monolithically, a bit like reconciliation, but is actually still relatively understandable. You know, objects update in a certain predictable order. You can very easily tell what's going to get updated by what. Right, you know, a computed object will update after the state object that it depends on, that sort of thing. It's quite well defined in comparison, and the level of abstraction is not higher than it needs to be. So I think that a lot of confusion about why Fusion isn't magic is largely down to working at this much lower level of abstraction. We're sort of, to use an analogy in terms of programming languages, it's like getting somebody who's only known scripting languages all their life to use C++. They assume that C++ should be doing more for them, that C++ should contain more magic, without realizing that C++ is intentionally not magic, because you're getting that really low-level, granular control. You're getting that control over things like performance and optimization. And in fact, a lot of C++'s default utilities may even guide you towards better optimization by default, without you realizing it, in a similar way to how Fusion might do. Now, of course, this analogy breaks down if we go much further than this, so don't read into it too much. But generally speaking, Fusion is not magic. Don't expect it to do magical things for you. And if you ever get stuck, just think about what the simplest possible solution would be, and you're probably on the right track. Anyway, I hope this helps you out, and I will see you guys around. Have fun.